Hi, my name is Victor. Welcome back to the Victor Learning Hub channel. And today we're going to be going through some simultaneous equations. So I had a lot of requests from the general math students to go through these questions as they've been struggling with these questions recently throughout their studies. So hopefully this video gives you a little bit of insight into how to approach simultaneous equations better and how to use the two methods which we're going to go through, which is going to be using the substitution method in the first question here, and we're going to be using the elimination method in the subsequent question as well. Okay, solve the following pair of simultaneous equations using the substitution method. So we've got 3x plus y and equals 8 and 2x minus y equals 7. So first of all, as you usually do with your process, make sure you label what the equations are. So let's label equation 1 as 3x plus y equals 8. Let's label equation 2 as 2x minus y equals 7. So when we're talking about substitution method, what that talks about is that we need to isolate one of the x or y variables for itself. So we're basically trying to form a new equation. So what we need to do is rearrange one of these equations to isolate just the variable x or y. So I'm going to choose 2 because I think that's the easiest. So I want to isolate the y actually here. So what I'm going to do is rearrange this equation so I get the y on its own. So first what I'm going to do is move the 2x to the other side. So that's going to be, so let me just write the equation again. So I'm going to need to minus 2x on both sides so I can cancel out the 2x there. So that's going to be negative y equals negative 2x plus 7 or 7 minus 2x. It's the same thing. And now since this y still is a negative, I want to make it a positive y. So I'm going to be multiplying it by positive 1. Sorry, not positive 1. Sorry, I want to multiply by negative 1. Multiply this by negative 1. So that's going to be y equals negative 1 times negative 2x plus 7. Making sure you times it by the whole thing as a factor in front. Okay, so y is going to be 2x minus 7. Okay, great, awesome. So now we've got that. Now we can substitute this in to equation 1 right here. So let's name this equation a new name, I guess. So let's say this is equation 2a now. So we can say in our steps, sub in equation 2a into equation 1. Okay, so let's just sub that in now. So we've got 3x plus 2x minus 7 equals 8. Okay, so that's 5x minus 7 equals 8. Now I'm going to want to put the 7 to the other side, so I add 7 to both sides. So that's going to be 5x equals 15. And then after that, I'm going to divide on both sides by 5. So divide by 5, divide by 5. Therefore, x equals 3. Great, so we have got one of the variables. So now the next step of what we're going to do is actually sub in x equals 3 into one of the equations. It could be either equation 1 or equation 2, but I'm just going to stick to equation 2 since we've been focusing on that. So sub into I'm going to stick to equation 1 since we've been focusing on that before. So let's sub into equation 1. So what's x equals 3? So 3 multiplied by 3 plus y equals 8. 9 plus y equals 8, minus 9 on both sides to get rid of this 9 here, minus 9 minus 9. So that's going to be y equals 8 minus 9. Therefore, y is going to be negative 1. Okay, great. So we've done that. Now, one good thing to make sure to be confident that you're right is to do something called a check. So we can check with either of the equations. Let's just use equation 1 again, which was 3x plus y. If you don't understand what a check is, it'll make more sense in a moment. So all we're going to do is actually sub in the values we've got. So we've got x equals 3 and y equals negative 1. So I'm going to write those down. X equals 3, y equals negative 1. Sub those in. 3 multiplied by 3 plus negative 1 equals 8. 9 minus 1 equals 8. 8 equals 8. That means this equation is good and we are right. So there we go. We've just basically isolated the variable to make equation 2a right here, and we subbed it back in to equation 1 here, and we have found x and y, and we've checked that as well. Okay, next one. Solve A pair of simultaneous equations representing the number of adults A, okay, adults stands for A, and children C, attaining the zoo is shown below. So we've got equation 1, which is A plus C equals 350. Equation 2 equals 25A plus 15C equals 6,650. By solving the pair of simultaneous equations, determine the total number of adults and children attending the zoo. Okay, the total number of adults and children attending the zoo. Okay, great. So all this is really asking for here is that we're trying to find what A is in terms of the amount of adults, and we're trying to find what C is in terms of the amount of children. So it's pretty much all you got to do is going to be using the elimination method here. You can use substitution here, or but I think I'm just going to go through the elimination method here since I already demonstrated how to use the substitution method before in the previous question. So let's write down our equations. So equation 1 is A plus C equals 350. Forgive me for my handwriting. Okay, equation 2 is 25A plus 15C equals 6,650. Okay, so what I'm going to do with the elimination method is that you want to get one of the coefficients of the variables to be the same of the other equation. So what I mean by that is that this number here, which is 1 so far, it's because it's 1 times A and 1 times C. I want A to either become 25A or I want C to either become 15C. So I'm just going to do 15, make C become 15 because that's just the lowest coefficient I can do at the moment. So I'm going to multiply equation 1 by 50, the whole thing. That means, let's just call this equation 1A. I'm going to get 15A plus 15C equals, so let's do 450 times 15, 0, 25, 2, 15, 17, 0, 5, 3, 0, 5, 12, 1, 4, 5. So that's 5,250. Great, so now we can eliminate these equations. So we're using equation 1a. I can use equation 1a now to subtract equation 2. So now I'm going to subtract those two equations. So if you want to write it again to make it easier to understand, just write the equations on the top of each other. So 15a plus 15c equals 5,250. Then we've got 20, and then the other equation we have. This is equation 1a. Equation 2, we've got 25a plus 15c equals 6,650. Okay, so now I just want to subtract these. So we need to subtract these numbers right here, the constants and the two coefficients. So we can just rewrite this 15a minus 25a. And then obviously these 15c's are going to cancel out because we made their coefficients the same. Okay, and now we can do 5,250 as well with our constant, minus 6,650 if I'm right. Yes, 6,650. Okay, so 15a minus 25a, that's negative 10a. These just cancel out because they're 0, so you can put plus 0 here if you want to, but it's not really necessary. Okay, that's going to be 5,250 minus 6,650. That's negative 1,400. Okay, great. Now I can just divide negative 10 on both sides. Okay, so that means therefore the number of adults is going to be 140. Awesome, great. So now we've found the number of adults. Now we need to find the number of children. So pretty self-explanatory right here. We want to sub in A of equals 140 into one of the equations. Let's just sub it into equation 1 because that's the easiest. There's not too many numbers here in coefficients. So A plus C equals 350. Let's write that down again. A plus C equals 350. So we can sub it into the equation now. So 140 plus C equals 350. So therefore C is going to be equal to 210. Okay, so yeah, that's what we've done. So we've done part A, so we can take that off. Okay, so now part B. In the context of the problem, explain. So we need to explain what equation 2 represents, so the context of the problem. So if you get something like this where you need to explain, just link it back to what the actual question is trying to ask you. So it's saying that these adults and children are attending the zoo, and these two equations represent it. So if you just look at it really closely, you can actually think about it as sort of a cost in a way. So 25A plus 15C equals 6,650. 6,650, this is quite a big number, and 350 is quite a low number. So the key thing you need to look out for here is, as I said before, what the coefficients mean of the variables. So 25 multiplied by A plus 15 multiplied by C. So the way to interpret this bit right here is that it's $25 per adult to enter the zoo. And then for 15C, it's $15 per child to enter the zoo. So if I had two children, for example, two children, that would be $30. If I had three adults, that would be $75. So hopefully you can see how it's being represented here. And then equation 1, all equation 1 is saying is actually it's just the number of adults and children attending the park. And that's why you can use the simultaneous equations to find out the number of adults and children attending the park. So this is basically actually the total, I should say total number of children and adults attending the park, because we got plus here, so that's going to indicate a total amount. So that's what B means. So we've done B as well. All right, thanks for watching.